So against the topic 1, that is introduction to inventory and materials management, now I am now going to discuss the second topic, and this topic deals with the two aspects. One is the reasons of inventory. Why do you need inventory? It should be very clearly understood, and the classification of the inventory problems. Already we have the classified the types of inventories. There are different types of inventories based on the state, based on the utility. We have already studied this one. We have classified the inventories. Now, in a given situation, you can come across different kinds of inventory related problems. So, the first thing you need to do is classification of the inventory problems. So, you need to know that what are the factors actually contributing to a specific kind of inventory problem, and these factors are common to any kind of inventory problems. So, you need to identify the factors, and then you need to study each and every factor, and then you need to consider the different the combinations of these factors to identify the kind of problem you are facing right now, or you may be facing later on. So, the inventory is needed to meet demand. Right now we are discussing the issue, that is why inventory? Why do you need inventory? Suppose inventory is not there, what would happen? Demand occurs at instant of time or during a period of time. That means what I am saying, that at this point in time the demand of 10 units has occurred at this point in time. So, if there is a demand and you need to meet the demand, how do you meet the demand? You need a supply. The supply of what? Supply of inventory. That means at any instant of time, suppose there is a demand of 5 units. So, in order to meet the demand at the same point in time, you need a supply of 5 items or the 5 units of a particular item. So, this is an inventory. So, essentially when you talk about the inventory management system, we are referring to the relationship between the supply and demand, and how best you can create a condition where the supply and the demand is having the best possible, they are having the best possible relationships between them. So, inventory is needed to meet demand. Demand occurs an instant of time or during a period of time. If supply is made as and when demand occurs, okay, this is if this is possible. In many a time, in majority of the time, this is not possible. There is no need of inventory. There is a perfect matching, a perfect match between supply and demand. Is it okay? So, this might happen in certain cases. And if that is the ultimate goal, that means we say in many cases that can you create a condition where the supply and demand are matching exactly at any point in time. So, obviously if you create such a condition, there is no need of having inventory. However, such a condition in all likelihood, is it okay, can rarely be achieved due to many kinds of practical difficulties and constraints. Is it okay? Like, can it be possible to arrange instantaneous production or supply as soon as the demand occurs? Is it possible? In majority of the cases, in almost all cases, it is not possible, because you need to produce and the production takes time. You need to make the supply, and the supply takes time. So, even if with demand of small quantity and there is on time or online real time information control systems. So, even if there is an online real time information control systems. So these days you will come across the online real-time control systems, the information systems is constantly being updated. So even if you have that kind of system related to inventory management, so in many cases, many companies, they have they adopted computerized inventory management systems with several modules, the several functional modules. Is very common practice these days among in many organizations throughout the world. Creation of inventory with its acceptable value, quality and quantity needs certain time. You cannot create the inventory instantly. So the creation of inventory with its acceptable value, that is most important. Is it okay if in a hurry you produce the inventory but it doesn't have adequate value, then obviously don't call it an inventory, and that way you cannot meet the demand. So the quality of the inventory, the quantity of inventory, and ultimately the value of inventory, you must ensure. So in this context, there are 4 possible reasons for existence of inventory in any system. So what are those? These factors are, first is the time factor. So you need time to produce the inventory, and then only you can supply it. Is it okay? So first one is the time factor. The second one is the discontinuity factor. That means what do? You keep inventory in sufficient quantity, in sufficient amount in advance. Right now you have as a production system. Now there could be a discontinuity in production system, there could be discontinuity in the supply. There are many the factors and making the systems uncertain. So there could be many discontinuity factors. So what you try to do, in order to take care of this factor, what you do, you keep some extra inventory. So this is the second reason. Third reason is obviously the uncertainty factor, right? So many of these problems you will find coming under inventory, these are basically the problems under uncertainty. That means even the demand is not known. Sometimes the demand is low, sometimes demand is high. Is it okay? So when the demand is low and you knowing fully well that it could be high in the next season, so why do you have you must have a capacity, and at this point in time when you produce to capacity, you may have some extra stock, but these extra stock you can use in the next season when the demand is more than the capacity. So this is also one of the reasons, uncertainty factors. And the last one is the economic factor. So let us elaborate briefly about all these factors. The time factor is the creation and supply of inventory needs time. Is it okay? That's why you need inventory. The second one is the discontinuity factor. As each stage of production must act independently from other stages or processes, production and post-production phases. This I have already mentioned, like say we mentioned about the the decoupling inventory. Inventory allows a process or a stage to act independently even if there is discontinuity in operation. Is it okay? Due to some reasons at the precedent or the subsequent process or stage. It's clear? So this is unavoidable. So discontinuity factor, because of the discontinuity factor, you must have inventory. What is uncertainty factor? Inventory offers protection against unplanned or unanticipated occurrence of events that may affect supply system. Such factors may be of many types, including acts of God. So these are the uncertainties. So sometimes you have a condition where you can produce to capacity, but if suppose there is a sudden the breakdown of the machineries or the production systems is shut down, what do? You can't produce as per the capacity. So it is better that when the system runs at its capacity, so why don't you utilize its capacity fully? Even if the demand is less, let the production quantity be more than the demand, so that if there is an occurrence of the shutdown or the breakdown, you have the extra stock, and because of this extra stock you can fulfill the demand occurring at that point in time. Economy factor: inventory offers cost reduction advantages when bulk purchases with quantity discounts is allowed. This is a common practice everywhere. If you produce, if you demand, demand more, or if your requirement is more, so you are allowed the quantity discounts. So there are some advantages in reducing the total purchase cost. So when the quantity discounts are offered, so obviously the quantity discount is offered at a particular the level of, or at a particular quantity. So maybe if you make a supply offer, if you have a demand for 10,000 and you want to purchase 10,000 units, so the unit price quoted may be 10 rupees per unit. Whereas if it crosses 10,000, suppose your demand is 15,000, you may get a reduction of say 20%. So that is the price discount is offered. So because of this quantity discount or the price discount, there will be overall gain in your the total purchase the cost. So that's why the discount is accepted. So the economy factor becomes prominent when procurement at lowest price in condition of seasonal price fluctuation is justified. Now, so we know that why we must have inventory, and but this inventory amount or the amount of inventory is to be determined logically, scientifically, and following certain principles. So those details we will come to know in course of time. Now, how do you classify the inventory problems? That is the core issue. So before you attempt to classify inventory problems as they exist in manufacturing or service organizations, it is pertinent to know what is to be determined related to inventory management for an item or for specific questions need to be answered against an item. Is it okay? So that means what is this inventory problem? That means related to a particular inventory item, what do you need to do? That means the two questions are to be answered. The first one is when to order for this item. It must be known whether at any point in time or at a particular point in time. Is it okay? So the time, so related to time, there will be this question and you have to answer. The second one is how much to order for this item. If you at any point in time, suppose you decide to, there must be certain rules, you will come to know all these rules. So suppose you decide at any point in time t equals to t that you have to place an order. So the next question is asked that what will be the quantity, what will be the order quantity. So how much to order for these items. So remember at any point in time, whatever may be the inventory problem related to a particular item, whatever may be the constants, whatever may be the conditions, these two questions you have to answer, right? And these two questions are answered in various ways. So there are two parameters related to above questions. So these are the two questions we have related to time and related to quantity for any inventory control system. A number of factors affect this inventory problem. Each of these factors may have different levels. Is it okay? So the first we'll identify the factors which actually determine an inventory problem, and then we'll look into each and every factor and the details of these factors under how many different ways the factors can be leveled. So this also we'll understand. We'll identify those levels against each factor, and then we'll be able to classify the problem. So this the classification process we are going to discuss in a systematic manner. Combinations of the types and levels of these factors determine classes of inventory problems. That means each combinations will identify when all the factors and their levels are known, when you can establish different combinations. So we'll count how many different combinations. So you may find that one combination is the simplest problem and another combination is the most complex problem. So you also must understand that why it is a simple problem, why is another combination is treated as a complex problems. In the real world, what we will find that almost all sorts of the problem types you come across, starting from the most the complex or say the most simple to most complex problems. And you must have the ways and means, you must have the tools, techniques, approaches to the formulate all kinds of problems and need to get a solution. And the solution will lead to answering two specific questions, that is when to order, how much to order. So the first factor, so all the factors we need to briefly describe at this stage. You please note them down, all the important points. The following factors need to be considered for classification. The first one is the knowledge of demand. First factor is the knowledge of demand. Demand for the item. You must have this knowledge. This is the starting point, because you are creating an inventory system essentially to meet the demand. So the demand may be of two types. The first one we call it independent demand, like the demand of finished goods. So it's basically this demand depends on the market conditions. So the market asks for a particular, so the finished goods or the final product. Okay, so it doesn't bother about the materials. It doesn't bother about the demand of the WIP. Is it okay? Or MRO items. So this is referred to as the independent demand. Is it okay? So the demand of the finished goods or the demand of the final product. Or there could be dependent demand. So what is dependent demand? That means demand of raw materials. Is it okay? Amount of raw materials you require to produce 1 unit of finished goods or the final product. So this the demand of raw materials, just for an example, depends on demand of finished goods as per bill of material of the finished goods. So for the finished goods or say the final product, obviously there is a bill of material. That means to produce 1 unit of output, how many different types of the different types of say the components, parts or the sub assembly is you require. So that is very clearly the mentioned in the bill of material document. So for 1 unit of say the output, that means the finished goods, if you refer to the bill of materials, you will be coming to know that how much raw materials you require, how many parts in which quantity you require to produce 1 unit of output. So accordingly you determine when the demand the quantity is known for the finished goods. So obviously for each part, for each raw material, you will be able to know what is the actual quantity required. So this is the dependent demand. Then the demand could be constant. That means the demand is under certainty. That means what we say that the problem under certainty. That means demand is known with certainty. Demand known with certainty. Demand level is known exactly. We say that okay, my next week's demands for this item is 10 units, then exactly 10 units. So such cases that do happen, even if rarely, but sometimes this is there are cases when the demand is known with certainty. We'll refer to these cases later on, okay, and you will come to know that it's not that rare. Now, the next the type of demand is obviously the variable demand. This may be defined in two ways. The demand under risk, when the probability distribution of demand is known. So this is one case. And the second case is more complex. The demand, there will be demand, but the exact level of demand is not known. So this is referred to as the demand under uncertainty. Even the probability distribution of demand is not known. That means either you don't have any the past data, this is the first time the demand has occurred, that could be the case, or the situation is such that you cannot make any conclusions about the demand pattern. Is it okay? So how can there be any the demand distributions? So when even probability distribution of demand is not known, only partial information related to demand is made available. So this case also will be dealing with. There are approaches, there are techniques with which you can solve this problem. And particularly, to what extent, just to make a note that particularly this partial information in many a time we can explain or in terms of the moments of the distributions. Even if the distribution the type is not known, but you can calculate the moments of the distribution, first moment, second moment, third moment, fourth moment, and if you calculate if you for a given item with the data, if you can calculate up to the fourth moment, okay, you will have sufficient information, and obviously there are approaches with which you can determine the order quantity as well as the ring interval. The next important factor is the source of supply. So this may be of two types. First one is the outside supply case. That means the item is procured from outside supplier. So most of the cases, almost the 40 to 70% of the items, the listed in bill of material for a discrete type, discrete type manufacturing systems, or say the typical, the batch type production systems, you will find they are all procured from outside. Whereas there are cases where you need to have self supply. So this is referred to as the inside supply. So both the cases we will consider. The modeling will be done for both the cases. Item is supplied from inside. This is called a self supplying case. Decision process repetitiveness, that is the next factor. This may be of two types. One period decision, that means only for a specific time period the demand occurs. So it is a one time decision. The next time period the demand doesn't exist. There are many such cases you come across where you need to take a decision just for once. That means it is referred to as the one period decision. So this is referred to as the static inventory problem. So you need to have a single order in all likelihood, because usually such cases the selling season or say the period, the time period is maybe a few weeks or say maybe 1 month. Is it okay? So you decide to have just one order, okay, for meeting 1 month's demand. Specific time period during which only the demand exists. Is it okay? Just for 1 week or each day a particular newspaper is sold in specific quantity. So the next day you place a different order quantity. Is it okay? So it varies. So obviously it's a one period decision. So this type of problem is referred to as a static inventory problem. But there are cases, there are items, inventory items, these items are regularly used, mainly for the production purposes. So for which you have to take a multi-period decision, dynamic. So whenever you come across, or you have to take a decision, not only today, every month, every year. Okay, decision maybe the different kinds of decisions you might have for different the time periods. So this problem is referred to as the dynamic inventory problem. Repeat orders you have to do. Demand exists for countably infinite time period. Is it okay? So the company's product is being produced for the last 50-60 years, and I'm sure that the next 30 years these products will be made available in quantities. So this is the typical dynamic inventory problem case. Item produced regularly. Knowledge of lead time or the lag time. Okay, so what is the lead time or the lag time? The time between placement of an order and the receipt of supply. I repeat, the time of placement of an order and the repeat and the receipt of the supply. So this the time difference is referred to as the lead time or the lag time. So this is an important factor to be considered in inventory problem classification. Knowledge of lead time or the lag time, time lag in receiving order. That's it. Time between placement of an order and the receipt of its supply. I have already mentioned. This may be of two types: constant lead time, you assume it to be constant, and or it could be a variable lead time. So in the majority of the cases, say at least 60 to 70% of the cases, you will find the lead time is variable. Probability distribution of lead time is known or specified. Is it okay? So that is related to the lead time related factor. Now there could be different inventory control systems that you can impose on the system, right? So the practitioners over the years, they have been recommending different kinds of inventory control systems, right? You visit any factory, you come across different types of items, and so also different kinds of inventory control systems you may come across. And for a specific item, one particular type of inventory control system may be recommended. So for any item, its inventory control systems can be decided independently. Okay. A large number of such control systems have been developed by researchers and practitioners throughout the world. And many of such control systems, they find a place in textbooks on inventory management, and they are in use in different companies you visit. Different kinds of inventory control systems you come across. Is it okay? And all are useful. Among a large number of such systems, the following control systems are widely used. And while we discuss the inventory control, so the models in subsequent lecture sessions, we'll be referring to all these 5 types of the control systems. So these systems, all these systems will be learned in depth in course of time. So the first system is called perpetual. Just please note it down. Later on we'll discuss in detail. Perpetual or continuous review system. This is one kind of system. Next one is the periodic review system. For many kinds of items, this periodic review system is followed. Then we have the material requirements planning on MRP system. There are many versions of MRP system, and you will come to know later on that mainly the MRP system is recommended specifically for WIP type of inventory. Is it okay? Then you have the distribution requirements planning. This is very much there in the materials management systems. So this is very, very important, in fact, the distribution requirements planning. And and you must have the good quality distribution requirements planning systems, so that for the entire supply chain, that means from the inbound logistics to the factory systems to the outbound logistics, you can have a balanced flow of materials in different forms. So you must have that means entire inventory management systems of a factory, of a manufacturing system, must be supported by an adequate and the quality distribution requirements planning systems. And of course, the last type of systems, inventory control systems, also we'll be discussing, that is the single order quantity systems. So the over and above these factors as stated, the demand distribution over time may be assumed to be fixed, that is the stationary demand, or it might vary over time period. So initially we assume that whatever the distribution we'll assume for the demand as well as for the lead time, these distributions they remain constant, they are not going to change. Whereas there could be situations, there could be the assumptions regarding a particular type of distribution, they might change, and then if you assume different types of distributions over the time periods, then it is a non-stationary demand or the non-stationary the system. So either the demand distribution may be assumed to be fixed, constant, or it may be assumed to be a variable. So both the cases you come across while you modeling. So stationary as well as the non-stationary. Now the stationary system, when you refer to, we indirectly assume that the inventory system has become a steady state system. Is it okay? So in many cases, suppose the inventory system as such has been running for a long time, we may assume, this hypothesis we may have, that is the system has become stable or the steady state condition. So inventory control classifications may be depicted with the following figure. So this is the figure you refer to, like the multi-order dynamic, single order static. Then you have the supply outside supply, or it could be inside supply. Then there could be independent demand, there could be dependent demand. Then there could be constant lead time, there could be variable lead time. So you reach to this node. These are the nodes you have. Is it okay? And against a particular node, that means in this combination, it's a particular combination, you can either adopt P3 control systems, P1 control systems, P2 control systems, or P4 control systems. That means distribution requirements planning systems. Similarly, there could be other routes. Is it okay? So you have these routes. That means this is independent demand, this is also independent demand. This is the constant. So this is a dependent demand, this is independent demand. So for the dependent demand, you have the constant lead time, variable lead time. Is it okay? And for the dependent demand over here and independent demand over here, that means these two, 1, 2, 4, 1, 2, 3, 4, these 4 nodes are essentially for the dependent demand for both the cases, and you have just material requirements planning. Whereas this one is independent and this one is independent, so you have these nodes, and you can have either P1 or P2 or P4 inventory control systems. So similarly, we have all these routes. Is it okay? And all these routes are exclusively for the single order modeling. Is it okay? It's just a single order modeling, the static inventory problem under risk. So there could be outside supply or the self supply. There could be independent demand, there could be dependent demand. There could be independent demand, there could be dependent demand. Is it okay? So here actually this is a constant demand, this is a constant demand, and the constant the variable demand. This is the constant demand, variable demand, and this is the constant lead time, variable lead time. So this is either the demand could be constant or the variable, right? So ultimately we will have this single order modeling, that is referred to as the P5. So we have covered this important topic called the classification of inventory. So we will be going for the formulating almost all types of inventory problems. Is it okay? So there are many combinations. So thank you.